Welcome back. We're on problem number 12. Problem number 12. The perimeter of a rectangular plot of land is 250 meters. So the perimeter is 250 meters. If the length of one side of the plot is 40 meters, what is the area of the plot in square meters? All right, so let me draw a rectangle here. So let's see. We know that one side of the plot is 40 meters, right? Well, it's a rectangle, so if this side is 40, then this side is also going to be 40, right? And let's say we don't know what the other side, if this side is x, well, if this side is x, this is also x, right? So what is a perimeter expressed in these terms? Well, it's 40 plus 40, which is 80, plus x, right? So 80 plus 2x is the perimeter. And we know that the perimeter is 250. Is equal to 250. And so solving for x, we get 2x is equal to, what's 250 minus 80? That's 170. And then x is equal to, what's that, 85. Right? X is equal to 85. Equal to 85. And now if we want to get the area of this, we just multiply the base times the height. So 85 times 40. Put a 0 here, and 4 times 5 is 20. 4 times 8 is 32, plus 2 is 34. So the area is 3,400 square meters. I hope I didn't do something wrong with the math, but I think you get the point. Next problem. Problem 13. A school ordered $600 worth of light bulbs. $600 worth of light bulbs. Some of the light bulbs cost $1 each, and others cost $2. So some were $1, some were $2 each. If twice as many $1 bulbs as $2 bulbs were ordered, how many light bulbs were ordered altogether? Fascinating. So let x equal number of $1 bulbs. $1 bulbs. I could introduce a variable y, but I could just say that x is the number of $1 bulbs, and we know that twice as many $1 bulbs as $2 bulbs were ordered, right? So how could I express the number of $2 bulbs? $2 bulbs. Well, we know that twice as many $1 bulbs were ordered as $2 bulbs, so this would be x divided by 2. There are half as many $2 bulbs as $1 bulbs, right? And we know that if we add up the total number of bulbs, well, actually we don't know. So what is the total cost if we get x $1 bulbs and if we get x divided by $2 bulbs? What is going to be the total cost of this? Well, I'm going to get x $1 bulb, and they're each going to cost $1, plus I'm going to get x over 2 $2 bulbs, and they're each going to cost $2. And when I add it all up, it's going to equal $600. So x times 1 is, of course, x. And then x over 2 times 2, that's lucky that worked out, plus x is equal to $600. So 2x is equal to 600. X is equal to 300. And they want to know how many light bulbs were ordered altogether. So we got 300 $1 bulbs. And we got half as many $2 bulbs, right? X divided by 2. So we got 150 $2 bulbs. We got 150 $2 bulbs. So together we got 450 bulbs. Next problem. Image clear. I'll do it in a new color so we don't get bored. 14. If 4 times x plus y times x minus y is equal to 40, and we also know that x minus y is equal to 20, what is the value of x plus y? Well, we know x minus y is equal to 20, so we can just substitute that right here. So then we get 4 times x plus y times, instead of writing x minus y, we can just write 20 times 20 is equal to 40. Or if we multiply 20 times 4, we know that 80 times x plus y is equal to 40. Then we know divide both sides by 80, and we get x plus y is 40 over 80, which is the same thing as 1/2. And that's our answer. X plus y is equal to 1/2. Next problem. 15. In a rectangular coordinate system, that's what we're familiar with, the center of a circle has coordinates 5, 12. So I draw a circle, and then the center of the circle has the coordinates 5, 12. And the circle touches the x-axis at one point only. What is the radius of the circle? So it just touches the x-axis. And the only place where it can touch the x-axis only at one point is this exact, because the x-axis is essentially a horizontal line, right? And where else could you touch the x-axis? Well, you could touch it here on top, but if the x-axis was up here, then the y-coordinate would not be positive. So this has a positive y-coordinate, so we know it has to be above the x-axis, right? It's at 12. So we know the only place where you can touch the x-axis just once is right here, right? Just right at the bottom. So it's got to be like that. That's got to be the x-axis, and of course, well, I'm not gonna. If that could be the x-axis, and then the y-axis could be out here someplace. Just so you have a frame of reference. And if that's the x-axis, then what's the radius? Well, this is the point 5, 12. This is, of course, this is y equals 12. So what is this height? This is a radius. Well, that's just the y-coordinate. It's 12. So the radius is equal to 12. And that is, yeah, they're just saying, what is the radius of the circle? Well, the radius is 12. This is the y-coordinate. Next problem. Oh, whoops. I say whoops a lot. Problem 16. And they have this, let's see, men, women, woman, and then they say voting age population. So population, and then registered. And they say 1,200, 1,000, 1,300, and 1,200. Say the table above gives the voter registration data for the town of Bridgeton at the time of a recent election. In the election, 40% of the voting age population actually voted. So this is the voting age population. And we know that 40% actually voted. If the turnout for the election is defined by number who actually voted versus divided by, so number voted divided by registered, what was the turnout for this election? So what's the number who actually voted? It's 40% of the voting age population. So 40%, what's the voting age population? Well, the total population is the men and the women, so that's 2,500. Just added these two up. And what's 40% of 2,500? That's 2,500 times 0.4. Say 4 times 25 is 100. 2 more zeros, 0, 0. And then, of course, one decimal, so it's 1,000. So 1,000 people voted. I just took 40% of 2,500. 1,000 people voted. And if we want to know the turnout, we just have to say the number voted, which is 1,000, divided by the registered voters. Well, the registered voters, there's 1,000 men, 1,200 women, so you add that up. So that's 2,200 total registered voters. So that's the same thing as 10 over 22, or 5 over 11. And that's our answer. That's the fraction that voted, right? That's what they wanted. Right, defined to be the fraction. So you could write it as this fraction, 5 over 11. I'll see you in the next video. Hopefully I didn't make a math error. Oh, see you in the next video.